Right, so continuing on from our last lesson looking into exponential expressions and logarithms, this time returning just to exponential expressions, but with a focus on what it means to work with rational or fractional exponents. Now, hopefully you've learned all this already, so I can go through this fairly quickly because ideally you've been introduced to this in previous courses. But in general, what does the power of 2/3 mean? Well, it means one of two things that are equivalent. This means 8 to the power of 2, but also cube rooted, the cube root of 8 to the power of 2. The denominator tells me the type of root, and the numerator tells me the power here, which is the same as the order doesn't really matter. It's also the same as the cube root of 8 first, and then raising that all to the power of 2. And quite often this is more convenient to work with, especially if we're not using a calculator, because the cube root of 8 is just 2 to the power of 2 equals 4. But it doesn't really matter, it's the same either way. And so keep in mind, I now know that 8 to the 2/3 is 4. And so negative 8 to the 2/3, if there's no brackets, means literally negative 4. The negative has nothing to do with the power. It's really a coefficient of negative 1 times 8 to the 2/3. And so I can just take my answer from before, which was 4, and multiply by negative 1. There we go. If there's brackets around this, that means something different, which will come up very soon. If the negative's in the exponent, well, that means this is the equivalent of 1 divided by 8 to the power of 2/3. Right? A negative exponent can be written as a positive power, but the reciprocal of it. And then again, 8 to the 2/3 equals 4. So this equals 1/4. And now, going back to what I mentioned before, what if I have negative 8 as being the base? Well, now the negative 8 is being raised to the power of 2/3 instead of positive 8. And so this means, like before, the cube root of negative 8, which is a real number, all squared. The cube root of negative 8 is negative 2, and 2 to the power of 2 is positive 4 again. And so keep in mind, even though the first one and the last one equal the same thing, these all mean something different, and they're all related. And so what if I have a rational expression like 16 over 25 being raised to a fraction like this, a fractional power? So a power of 1/2 is just a square root. So there's a few ways of approaching this, but one way is just to write this as 16 to the 1/2 over 25 to the 1/2. And now think of each of these separately. 16 to the 1/2 means the square root of 16 divided by the square root of 25, both of which are quite pleasant. I get 4/5. And so 16 25ths, the power of a half, same as 4/5, the square root of 16 over 25. So power of 3 over 2 is really the same thing as before, but all raised to the power of 3. This question here is really the same as this question here, being raised to the power of 3. And so I'm just going to take advantage of that and just use my work and realize that this is going to be the same as 4/5, but all cubed, which in this case is 64 over 125. All right, then I have the same thing as the first question, but I have a negative power, which means my answer will be the same as my first question, but it'll be the reciprocal. And so I'm just going to go straight to that. This must equal 5/4. And that again goes back to things we've learned before, that a negative power is the reciprocal of a positive power. And lastly, this one here, a lot of negatives going on. Now, a common mistake is to think these cancel each other out. But again, we're not multiplying them. It's a negative base to a negative power. So what does this mean? Well, let's write it first with a positive power, which makes it a little easier to understand. This is the same as 1 over negative 16 over 25 to the power of 3/2. So that's what it means. Which, what does my denominator mean? That means 1 over the square root of negative 16 over 25 all to the power of 3. That's it. This is where I realize I have a bit of a problem, because the square root of a negative number is not a real number, which means I can't actually evaluate this with real numbers. And so this is not a real number. Now later on in this course, in the HL section, we will really go into a decent amount of detail about complex numbers, which have imaginary numbers as part of it. This can be evaluated. We can evaluate this, but not with real numbers. Part of our answer is an imaginary number, which has to do with the square roots of negatives, which we will deal with at a later time, so let's not bother ourselves right now with that. All right, on the back, simplifying these, I got x to the 3/2 times x to the -1/2, all to the power of 3. Lots of approaches. I'm going to first put these together. I'm multiplying two powers at the same base, so I can just add my exponents. And so I get x to the 3/2 plus -1/2. Same as 3/2, take away a half, which is a whole. So this is just x to the power of 1. Now all of that is still being raised to the power of 3, which means my answer is x to the power of 1 raised to the power of 3, which is x to the power of 3. Lots of other approaches of getting there, but it should all come to x to the power of 3. All right, so over here, getting fairly messy, but I want to clean this up as much as possible. One thing I would do before I do much is to look at my base, which is a lot going on, and see if anything can be simplified here. But there isn't. I don't have the same variable in the numerator and the denominator, and neither 16 nor 81 has a common factor that I can use to simplify this. So, but I'd always look for that first, but there isn't. So I have everything inside here being raised to the power of 3/4. So everything, including the 16 to 81, I want to raise to the power of 3/4. Which brings me to 16 to the power of 3/4, which I'll get to in a bit, times x to the power of, we have 5/2 times 3/4, right? You have a power raised to another power, you multiply your exponents, and so this is just 15 over 8. And my denominator, I have 81 to the 3/4. Easy to forget about those coefficients there. And then y, and I have 1/4 times 3/4, which is 3/16. All right, all that's left is to evaluate these parts here, because 16 to the 3/4 and 8 to the 3/4 we can evaluate quite nicely. 16 to the 3/4, sorry, means the 4th root of 16, all cubed. The 4th root of 16, it's a weird looking 16, it has horns. There we go. The 4th root of 16 is 2. 2 to the power of 3 is 8, and so 16 to the 3/4 equals just 8. X to the 15/8 doesn't simplify, so I'll leave it like that. Over, if I do the same thing for 81 to the 3/4, the 4th root of 81 is 3. 3 to the power of 3 is 27. It's getting tough to make this remotely neat because I got so many exponents going on here, but there's my answer. And nothing more simplifies. If they were the same variable, if those are both x's or both y's, I could simplify them down to a single variable, but they're different, so I am done. Lastly, this time I want to simplify this expression, but I want my answer to have, no, I don't want any fractional exponents, so I don't want any exponents like this in my final answer. That's it. That's for my final answer. First, let's just simplify this. And again, lots of approaches, but one thing I notice is that I have 2x squared all being raised to the power of 1/2, which means I can raise each of these to the power of 1/2. So I have x to the 1/3, which I'm just ignoring for a little bit, times, I don't like using a time symbol, an x for a time symbol when I have the variable x, I'll just put a dot, times 2 to the 1/2, easy to forget about that part, times just x, or x to the power of 1, because I have 2 to the power of 1/2 is, or sorry, 2 times 1/2 is 1 whole. All right, so everything there, same as that. At this point, I have two factors with a base of x, so let me put those together. So I'll put 2 to the 1/2 first. And then here I'm multiplying two powers at the same base, so I can add 1/3 plus 1, which is 4/3. And now I'm done, aside from the fact that we were requested to leave our answer without any fractions in the exponents. And so really, anytime I see a fraction or a rational number in an exponent like this, I can write it with a radical or a surd. They're quite often called in IB resources. And so 2 to the 1/2, that means the square root of 2. So again, I was requested to write it without any fractions in my exponents. So there we go. I don't have a fraction in that exponent anymore. And x to the 4/3 means, again, the cube root of x all to the power of 4. Or I could write it like this, the cube root of x with the power of 4 in there. These are both good, both the same thing. And notice my answers, I don't have any exponents that are fractions.